So today I'm going to talk about some principles behind crypto-enabled networks, aka decentralized networks. I'm going to start off with some thoughts around decentralization. So we've seen a ton of projects in a short time, and I feel that we observe that pretty much every centrally mediated network today that we see, of the Ubers, Airbnbs of the world, is up for grabs in a decentralized way. So you've seen a lot of teams and projects trying to decentralize what the currently centralized networks today. But then one of the things that we also observe is that there's a wide variance in how complex and practical it is to decentralize certain kinds of networks. So in general, I think if your network exists solely in the digital realm, it's a little easier to decentralize than if your network actually touches the real world, like Uber or Airbnb. And then, there are also decentralized networks out there that existed before crypto even, existed. So things like Tor networks, or things like mesh networks, or even, BitTorrent networks, or the internet itself is decentralized. But if you kind of add crypto to it, if you design an incentive scheme around these networks and add crypto to turbocharge it, it could possibly work better. So those are what we call natively decentralized networks that could possibly be lower hanging fruits than some of the ones that we've seen out there. And then another thought is that when you decentralize something, you actually trade off quite a bit of stuff. So you want to make sure, the obvious thing you trade off is decision making, right? So as a centralized entity, you can make decisions really, really quickly. You also trade off a little bit of user experience. In decentralized networks, users have to go get a token and then know how to hold private keys and then sign transactions and stuff like that, things that, outside of Silicon Valley, most people don't even have a clue on how to do. So you trade off those things. So you want to make sure that the benefits of decentralization is greater than the cost of doing that. So this is probably quite obvious to this crowd, but there are some common desired properties to all decentralized networks, and those are having open participation, having fairness in the network, meaning that participants in the network, when they transact with each other, it's always fair to every party in the Nash equilibrium sense. And then, of course, in decentralized networks, you need to have trustlessness, so you don't need a centralized mediator to do your transactions. And then, to ensure openness, you typically have a protocol that you publish openly and have the community review and iterate on. And then from that open protocol, you possibly have independent developers develop different client nodes that can interact with each other through that protocol. And then you want to ensure that people can participate in an anonymous manner, so you cannot discriminate or censor based on attributes that are outside of interacting with this network. So to ensure fairness, it's typically enforced by these three mechanisms. The first one is very obvious, is formal proofs, which is basically irrefutable math that you can use to prove that something has been done, or you have expended resources to do something. And then absent of that, or if you cannot find formal proofs to ensure fairness, you might want to think about doing something called staking or bonding. This is often called work tokens, where you put up some value as insurance against bad behavior. So you put up some value in escrow, and then you do the work, and then if somebody calls you out for bad behavior, those tokens get confiscated. And then one other mechanism you can use to ensure fairness is simply replicate work and have your peers verify that you're doing things honestly, and then whistleblow if things are not done honestly. And then trustlessness is the most obvious. It's really enabled by public key cryptography, which allows for holding value without a counterparty with self-sovereign ownership of value, and the blockchain itself, the data structure itself, enables atomic transactions with peers on the network, which guarantees that you have zero counterparty risk or very little counterparty risk. As we look at a lot of decentralized networks out there, we generally classify them into these two categories, and there might be other categories we haven't seen, to be honest. But the first category is around governing the commons, and the idea is that you have a common resource that participants want to collectively manage and use, and they need to agree on how to manage and use that resource. And then the second is peer-to-peer marketplaces, where the interactions or transactions between the peers are not mediated through a centralized party. And for the first category, governing the commons, most of the networks are generally optimizing for participation, so you want a lot of people to want to use that resource, and at the same time you want optimize for consensus agreement how to improve the resource and how to manage the resource. And then peer-to-peer marketplaces obviously optimize for liquidity of different sides of the market. Typically it's two-sided, but there could be marketplaces that are many-sided. You want to make sure there's always enough counterparties to trade with another side of the market. And of course, you want to reduce cheating. So let me just run through this non-exhaustive list of networks that fall in the first category of governing the commons. And the first one is very, very obvious. Bitcoin network and Ethereum networks, and most of the public chains out there are trying to govern a ledger, basically, a shared ledger. And besides, trying to make sure that it's open, fair, and trustless, and optimizing for participation and consensus, they also need to make sure that the records in there are fair and have integrity, basically. Meaning that, for the example of Bitcoin and Ethereum, there's no double spans, and it's immutable, so you can't change it easily. And you want to minimize malicious corruption by designing a scheme that is as incentive compatible as possible, so everyone's incentivized to do the right thing. Of course, we also see, people want to do decentralized communities, where these are shared spaces where participants interact with each other socially or for some other purpose. There used to be like decentralized Facebook, decentralized Twitter, virtual worlds, and game communities. And by the way, these properties are also very applicable to centralized networks as well, but using different schemes to enforce these properties. So for communities, you obviously want to optimize for engagement and reduce abuse. And the scheme from what I've seen is that it's very simple. You basically give reward for positive behavior, and you take away value when you see negative abusive behavior. And this thing is another commons that we are familiar with is open source projects. And I think most crypto projects are open source projects. So these are things that you build, artifacts that you build, software, hardware, or even media that are collectively built by the community. And you need to design a scheme to incentivize things like contributions for open source softwares like pull requests, bug reports. But you also need to ensure that it's fairly represented among the stakeholders. So, and then you want to minimize small groups of people having outsized influence over the project. So some of these schemes are kind of oriented towards karma points instead of just pure contributions, because each contribution is very different. So if you implemented a very important feature, you might get more karma points as determined by the community. It can use those karma points to stake decision making, so the project can make decisions based on a fair allocation of votes, basically. And then we have decentralized news, magazines, content, and these are basically outsourcing editorial tasks to the community. And you're optimizing for truthfulness, quality of content, and you want to incentivize people to post stuff and consume content at the same time, minimizing copying of content for other networks, and then, of course, minimizing fake news. And this one is also kind of curating content, but the subtle difference here is that you're curating the same content. You're curating a topic. So the previous communities are actually posting new stuff, whereas this one is, curating a certain topic like what is Bitcoin on Wikipedia, or a list of like the top, restaurants in Mountain View or something like that, where the community can decide collectively to offer opinions or offer new data to this common set of knowledge. So obviously you want to optimize for contributions, but more importantly, you want to optimize for curation. So you want a lot of eyes on the, just like Wikipedia, you have a lot of people checking new edits and stuff like that. And this also applies to Oracle. Oracle is a very difficult thing to do, where contracts need to interact with the real world. They need to know the outcomes of real world events, and you need someone to report the outcomes of real events, and you need to design a scheme to report that in a truthful manner. And of course, you want to minimize scam for this use case. And then the second class of networks are peer-to-peer marketplaces. And this is very, very obvious as well. This is, obviously, this is what Binance does in a centralized manner. But this is also a use case which I think has the strongest product market fit today, where people exchanging tokens for other tokens, or contracts for other contracts. And both centralized and decentralized exchanges are optimizing for the same thing: security, performance, scalability, privacy, and trying to minimize market manipulation. Except that decentralized exchanges are like a lot harder to achieve these properties. And a lot of these are unsolved, and a lot of smart people are working on it. And we've seen some projects creating networks and schemes to share commodity resources that we all have on our local computer. So things like compute, storage, and bandwidth. And we all have a lot of unused compute, storage, and bandwidth on our laptops. They want to incentivize the sharing of those resources. So you want to make sure that there's a lot of availability, there's a lot of capacity, a lot of people participating in it, ensure that performance is great, and then you want to minimize the abuse of this network for participants to use it for things like botnets or denial of service attacks, stuff like that. And then we see marketplaces for data as well. So things like medical data, even identity data for targeting, and data that come out of research institutions, or data that's been collected from devices. For these marketplaces, you want to optimize for the quality, integrity of the data, the provenance, the source of the data is extremely important. Of course, the privacy of the data is important in the case of medical data. And then you want to minimize leakage, because data, once the first buyer buys it, it could leak out and transact with participants outside the network. And this is the most interesting thing, and I alluded to the fact that decentralization of real-world resources is actually really hard, because number one, I think real-world resources are non-commoditized in the sense that they are differentiated in many ways, right? So for rides delivery, you have different human drivers, and homes are all different, built differently. So you have different qualities of resources, service providers, which means that this network has to provide discovery. They have to be very good at optimizing for discovery. So matching the right service provider with the people who want those services. And then the second point that's really hard is the proof of completion or proof of performance in the real world is extremely hard, because it involves humans and involves differentiated services. And then ultimately, if there's a dispute, it centralizes because the courts have to get involved. So it could never be totally decentralized. And of course, in a lot of these use cases, you need to have some level of customer service. And how do you do decentralized customer service is also an unsolved problem. Of course, you also need to curate because you had differentiated services. You need to keep out the really bad ones. Of course, you want to minimize disputes and, again, leakage outside, people transacting outside the network. So that's it. I mean, I want to give a quick introduction on what Binance Labs is because we're very, very new. We've been around about 2 months old. We're about 2 months old. We're a venture arm of Binance, which is a crypto-only exchange. Our kind of mandate is to invest in projects that are optimizing for long-term impact and value to the ecosystem, and ourselves are also doing that. So we invest in both tokens, equity, and anything in between. We're very open-minded as to what structure we invest into. We also recently announced something called the Binance Ecosystem Fund, which is a way for us to work with other funds with the same values and mission, a way to collaborate with other funds that we invest in. I think at this point, if we have time, we can do some Q&A. Yep.
Great questions for Teck.
Is there a platform that you preference in your investments, Ethereum, Neo, et cetera?
Is there a preferred platform that we, in terms of platform, you mean like, what do you mean? Like types of decentralized networks?
For your investments with your token investments you're just talking about?
We are open-minded where we don't, but there are definitely some lower-hanging fruit stuff that we need to solve before we even get to some of these use cases. If CryptoKitties could congest the Ethereum network, then we need to solve that. So there's definitely a priority in terms of how we look at projects. But we're also very, very, we take a very, very long view. So if you have something that has dependencies and we can see those dependencies being resolved, then we'll be happy to get involved as well.
Great. I think we have time for one more question on the side.
Sorry.
Can you hear me? Yeah. So my question is related to your survey data and also a follow-on question related to that. First of all, I mean, thank you for giving this very great survey. You probably done a lot of work, research what the market is. I'm just curious, where did you collect this data to make the summary of the conclusion you have regarding the type of network you are supporting? The second question is a follow-on question is some of the work, even Vitalik claimed that it's not ready to be developed yet or to be deployed yet. And what's your personal assessment on terms of when do you think the network will be able to support or the infrastructure will be able to support those type of networks?
There's a lot of echo, so I'm going to repeat the question, see if it's the right question. The first one, you're saying, where do I do the research on the different networks? It's a combination of us as Binance Labs talking to a lot of projects and also just discovering new projects that come on, that announce themselves. So really on the internet as well as the projects that we interact with. What's the second question again? I didn't quite get it.
The second question is more related. Some of the networks probably have some, you just mentioned some technical dependencies. For example, the scalability issues with the Ethereum, with any other chains as well. What's your personal assessment? When do you think those things will be all cleared that will enable all this potential network to be developed and efficiently get deployed as well?
You're talking about more scalable public chains out there. right? When it will.
That's one concerns, right? But there may be some other potential limitations as well.
Yeah, I think if you think about, a lot of people talk about CryptoKitties congesting the Ethereum network. So obviously we need to solve that. And I just mentioned that the exchange use case is actually the strongest, product market fit for crypto today.
Yeah.
And the requirement for performance and capacity and scalability there is like, I don't know, a lot more than CryptoKitties, right? So, so we're actively looking at scalability solutions. And it's hard to say. I mean, a lot of these projects are on the verge of launching, and we're definitely keep a very close eye on those projects. And of course, Ethereum, all the current blockchains out there, Bitcoin, Ethereum, they all have scalability solutions in play. Bitcoin is trying to offload to layer 2 and stuff like that. All those are possible platforms or places where we can, we can solve the scalability issue. And I think scalability definitely is the most pressing issue if we want to get to some of these use cases we're talking about.
Do you have a personal estimate, the timing, when do you think that will reach stage that become useful?
I think it's really hard to say. I think for blockchain projects, it's easy to deploy, hard to harden, right? It's like you don't know what kind of security model. Nobody has a formal model of blockchain security, so it's really hard to know unless you put it out there, put enough value into the blockchain, and it's kind of like a bug bounty where people try to attack the chain and find vulnerabilities. I think it takes time for these solutions to mature. Yeah.
Thank you.